My name is Meaghan. I work at Google. Although I work at Google, I don't work on the Kubernetes team itself, but I work on the team with Pivotal and VMware that works on Cloud Foundry container runtime. So I started on this team about a year ago when the team started, and since then I've learned a lot about Kubernetes. And in my previous job, I worked with a Spring web app, so I thought I would talk a little bit about how you as a Spring developer could use Kubernetes. And I'm mostly going to focus on how Kubernetes works, and then I'll do a demo showing Spring Boot, an application deployed on Kubernetes. Cool, so this is an overview, and as a warning, I made a lot of these diagrams myself, so they look like this. The people are people, if you can't guess. So this is kind of an example cluster view. We have a controller node that controls the work that's going on worker nodes. We have 3 worker nodes. I have 3 in the example I'm going to show later also. And then you deploy, the operator of the cluster would use kube control, which is the CLI for Kubernetes, to tell the controller node they want to deploy a workload, like this Spring Boot application. And then the controller node will handle scheduling that on the workers. Then if you have an application user, they can talk to your workload, the Spring Boot app, directly on the worker node. So Kubernetes uses declarative descriptions of state, which means you just say, this is what I want, and they'll handle dealing with the scheduling and provisioning of resources. Kubernetes just makes sure the actual state matches the desired state. And that provides a lot of things, so that means you can scale really easily, because all you have to do is say, I actually want 4 of those instead of 3. You can do updates, because you just have to say, use this image instead of this one. And you can get monitoring and self-healing of processes. And this can run on the cloud or in the cloud or on-premise. How does it all work? This is kind of a high-level overview, although it's really not that complicated. First, we have an API server, which handles all of the communication within the cluster. So everything talks through the API server, but the API server relies on etcd for storage. And then we have a controller manager process that just runs a loop, making sure that we have what we want to have. So that's whatever the operator told us that it wanted, the controller manager makes sure that that's there. And if it's not, we use the scheduler to schedule anything that's missing. And those processes all make up what we call the control plane, and they usually run on the controller node that we saw in the previous slide. And then we have all of our worker nodes, which run a kubelet process, and the kubelet monitors the workloads running on it to make sure that they're healthy and reports that back to the API server. And then we also have a kube proxy, which handles requests coming in from the internet and make sure that they find the right place in the cluster. When I say workload, usually that's called a pod in Kubernetes. Kubernetes has a bunch of different objects, and pod is kind of the most basic one. It's a group of containers that are tightly coupled, and they share an IP address. Each pod will get its own IP address, and they share a port space. And they also share volumes and life cycles. They live and die together. And usually we're talking about Docker containers when we say containers. One pod is typically one instance of an application, and they're not considered durable. So if something starts going wrong in a pod, it'll just get deleted, and an identical one will be created in its place. So before we go on, I just want to show you how you could deploy a really simple pod on a Kubernetes cluster. So I have a cluster here deployed that I used GKE to deploy, so it's actually managed, and it's running on GCP. And if I want to create a really simple pod, I can just say kube control create, and then this Nginx spec that I have. And the spec just says, like, this is a pod, that's the kind of resource I want. I want it to be named Nginx. It's in an Nginx namespace, and namespaces are a way of kind of dividing workloads and allowing some people to access certain ones and not others. And then I'm also adding a label, app Nginx. You can pretty much label any object in Kubernetes, and some other objects will use labels to find pods, for example. And then I just have one container, which is Nginx. I use this Nginx image, and I'm opening up port 80 on that container. So let's see what we got. So I have a pod. I can get more information about it. So you can see this is the IP address that was allocated to this pod. So if I just curl that IP address, I get the sample, like the Nginx welcome page. So that's a really simple example. Another thing you can do is you can select based on the label. So since this has app equals Nginx, it'll show up if I ask for pods with that label. Oops. Cool. So some other things you probably want from your cluster, if you have 3 of your pods running and one of them dies unexpectedly, you'd want it to come back without you having to do anything. If you, as this blue operator guy, decides you want 4 pods instead of 3, the controller node should handle that for you as well. You shouldn't have to worry about actually creating the pod. And this all is facilitated using another object called deployments. So instead of just deploying 1 pod, you can ask for a deployment, and then you can say, I want 1 replica or 3, and it'll make sure that you always have that many. This facilitates scaling, because all you have to do is update the number of replicas if you want more or less. It also lets you change the image really easily, which we'll see in the demo later. And you can do rolling updates and rollback of versions of deployments as well. And the way it works is using a replica set, which is another object, but it's not that important. But you might have noticed in this picture, it's kind of weird because the application user is directly accessing one of the pods. And earlier I told you they're not durable, so that pod might die and be rescheduled somewhere else, or it might have a different name. So how does the application user know where to get it? And also there are 3, so it could access any of those 3. They should be identical. What we really want is something that looks like this, where we have our application user talking to a load balancer, and then the load balancer will decide which of the 3 pods to use. And for that, we use services. Services allow access to a dynamic set of pods, so no matter what the pods are named or where they're running, you can access them the same way. It uses labels to find the pod, so when we said app equals nginx, we can tell the service, just send it to any pod that's named app nginx, or that's labeled app nginx, and it load balances traffic across the nodes. There are 4 types of services. The first one, cluster IP, that's used for if you want to access your workload, but only within the cluster itself, so other pods can access it. Node port, I actually think this one's really cool. So if you use node port, then it will allocate a high-numbered port on every single worker node. So I think it's like above 30,000 or something. It'll allocate that on every worker node, and even if a pod's not running on that worker node that is for this service, it'll reroute you to one that is. So it just handles it for you. It's pretty cool. And that's actually how the next one works, load balancer. This one actually provisions you as an IaaS-specific load balancer. So if you're running on GCP, you'll get one of the L7 load balancers provisioned for you, and then it'll send traffic to the worker nodes on their node port. So that's actually really powerful, because it also creates firewall rules for you, so you don't really have to handle any of the networking for your applications. And then external name is not one that's as useful, but you can use that to access services that aren't running in your cluster as if they are running in your cluster. And volumes are another thing that's cool. I think for Spring developers, you're probably not using a lot of persistence in your applications themselves, but if you want to run things that do alongside your application, you can use volumes to get persistence with Kubernetes. Host path lets you talk to, it mounts the pod onto a directory on the worker node, so you can access things that if you know they're on the worker nodes, you can access files, for example. The empty dir one is for scratch space, so it gives you an empty directory and then it deletes it when that pod is gone. And the coolest one, I think, is persistent disks, because if you ask for a persistent disk, you can actually get a provisioned persistent disk, and then it'll always be attached to the node that your pod is running on. So even if your pod dies and gets rescheduled somewhere else, the disk will be unattached and reattached to the correct worker node. And then secrets are used for sensitive information to get access to them in your pod. Cool, so most of this is just gonna be a demo. In the demo, I'm gonna deploy a Spring Boot application, just 1 pod. Then I will put a load balancer in front of it so we can access the application. Then I will make the application depend on Postgres. And the Postgres, we will also deploy in Kubernetes, and we'll use a persistent volume so the data doesn't get lost when the pods get lost. And then we'll scale it, so we have 3 copies. Cool. So first I'm gonna create one of the pods. And let's look at that file. So this is just saying, I want to name the deployment this. It's in the default namespace, and then I only want 1 replica for now. These environment variables we're going to ignore for now, but I'll show you later. And then I'm using this image, which is, I built this image out of one of the Spring sample applications. And I'm also going to show you how you can build an image for yourself when we modify it. So now we can see we have one pod running, and I'm going to expose that, which creates a service. And I'm going to use type equals load balancer, because the default is cluster IP, and I'll put it on port 8080. Cool. And the load balancer takes like a couple minutes to provision everything in GCP. So you can see here it says pending. That's because the external IP is not created yet. So it's going to create me an external IP, a load balancer, and all of the firewall rules to allow my nodes to be accessed on this node port. Oh, yeah, up over 30,000. It's 31264. So it does take a couple minutes, but yeah. We do have this cluster IP though, so, oh, what I was gonna say is we had to open up port 8080 because that's the port that we opened on the container. So there we go, we have an IP address. We did have pods. Yes, okay. So this is just like an app that stores messages, and it stores them in memory right now. So if I say hello as a message, that will get saved. But then if I delete this pod, we can see what happens. So now Kubernetes already rescheduled. Oh, that's the same pod. I didn't delete it. Oh, because I spelled that wrong. That's smart. Okay, well, it does really recreate them really fast. So you can see this one's running already, and this one's still terminating, so it can start them up faster than it can stop them, I guess. But then once we refresh this, we can see we don't have any messages because we didn't persist the data. So now we can deploy Postgres, and Postgres will use a persistent disk for persisting the data, and we can see how that works. So I'm going to create this Postgres instance. And what this is doing, this is how you get the persistent disk. It's actually doing a claim, which means it's going to create one instead of using one that existed. And then up here in my deployment spec, I say this deployment uses this persistent volume claim. And then when I create my container, I just mount the volume onto, or I mount the pod onto this directory in the persistent disk.
If you're creating a new one, what happens when you restart?
If the pods die, it will reattach the disk somewhere else. So it still knows that that claim, there's already a there's already a disk for that claim. So the claim won't get recreated. I believe it would use a different claim. I don't know, we can check. Right, and then for Postgres, we have to tell it this PG data environment variable, so it knows to mount onto this directory instead of the root directory of that disk. And the other thing I did is I already created a config map earlier that had the user and password in it. You can also use secrets for the password, but we are using a config map here. And so it can grab out of that config map these keys. A config map is just a way of, it's a key value store in Kubernetes for configuration information. Cool, so we created that deployment. I'm also going to create a service so I can access it. But this service is just going to be a cluster IP because we don't need to access it outside of the cluster. So we have this cluster IP, And then I'm actually going to update the config map to include that also because the application that I'm going to deploy is going to depend on that as well. Cool. And then we can look at how to build a Docker image for our Spring Boot app. So I have all of the code here. Cool. I already modified it to use Postgres because that wasn't the point of the talk, and I figured you probably already know how to do that. But so we're just going to build the code that I modified, and the only difference is that it uses Postgres instead of an in-memory store. So first we'll build it so we have a jar file. I guess it takes a second. Once we've built it, we can build a Docker image for it, and then push the Docker image to Docker Hub, and then we can reference it in our spec for the deployment. Or actually, we can just update the image in the current deployment. So I have a Docker file here, and what this does is it starts out from this like default OpenJDK 8 image, which contains Java, and then we're copying the target file that we just built from the current directory into that image, and then it'll be at app/app.jar, and we opened up port 8080, which we saw earlier, and then when you start it, you just run java jar and then that jar file. So we can do docker build let's see what it's called. Spring sample web UI, I think. And then you have to pass in the current directory. Oh, slash. Yes, thank you. You already know how to do this. And then I will push it. Oops. Cool. And then I can update the image on my deployment directly, and it'll update it for me. It'll actually create new pods and delete the old ones. What was the name of my deployment? And then you have to say, this is the container I want to change, which was named the same thing. And then we can pass the image we just created. Cool. And then we can see if we can catch it in time. Yeah, we can see this one is being terminated and this one is being created. And now it's running. We should be able to use the exact same service that we created before, which is the same URL here. Cool, so now we have the exact same application, and if we create a message, now if we go back, we'll see the message, and I can actually delete both of these pods, and it should persist. Ah, I keep doing that. Cool. So this Postgres one actually will take a second because it's probably being scheduled on a different node, so it's going to have to unattach the disk and reattach it to a new node. You can set a flag in your deployment to say you want them to be on the same node usually, but you don't have to. And I did not, so it'll take a second. While that's happening, we can also scale up our application. So I said we were going to have 3 pods by the end of this. So we can do that using, I spelled it right that time, scale. And you just pass in how many replicas you want. pods. Oh, I'm typing everything wrong today. Cool, and then let's look at our pods. And now we have 3. One of them is still creating. Now we have 3. And let's see if our data persisted. Yes, we still have our message. Cool. That was all I had. Thank you so much for coming.